Welcome to Matematika. Today we're going to do 1.5b, polynomial functions and complex zeros. We'll start with even and odd functions. There are two special types of polynomial functions based on the degree of its term of the polynomial. When can you say that the function is even? When f of negative x would be equals to f of x. Analytically, the function of f of negative x should be equals to x. So when we substitute a negative x into the function and simplify, the result should be the same as the original function. We're going to see that later on. Graphically, the graph of an even function is symmetric to the y-axis. So if this is your y-axis here, okay, this is the y-axis. When you fold the figure, try to imagine that you fold the figure, they are identical. They are symmetrical about the y-axis. As for the end behavior, as x approaches either in the positive or negative infinity, will be the same. Okay? Positive infinity or to the negative infinity will be the same. Either both approaching positive infinity or both are approaching a negative infinity. The degree of its term is an even function is even or zero. We'll get to know more about even functions later on. The next type is an odd function. When can you say that the function is odd? Okay? A function is odd if the f of negative x is equals to the negative f of x or negative of that function. Analytically, like when we substitute a negative x into the function and simplify, the signs of all the terms should be the opposite of the terms in the original function. Should be the opposite of all the terms of the original function. Let's try to figure that out later. Graphically, as well for the graph of an odd function is symmetric about the origin. So in this case, like here, if we try to look at the end behavior, one is positive and the other one is negative. Okay? Across the origin, our origin here is 0, 0. This means we can rotate the function 180 degrees around the origin. The graph would be the same, in the same position it was originally. Okay? It was originally. So if you try to figure out and then you rotate 180 degrees, okay? 180 degrees. The same, they are in the same position. All right? The degree of its term is odd function when is an odd function when it is odd. The end behavior as x approaches a positive infinity or a negative infinity will be the opposite one another. As I've said, one end is positive, the other end is negative. And if you can see that, then it is an odd function. As I've said, analytically or algebraically, we'll try to find out whether the function is even or odd by following the condition. I have here for number 1, okay? And this is an example of even function. We'll see that if the function of negative x would be equal to the function of x. Function of x is the given function. Say you have a given function of x to the fourth minus 5x squared plus 4. If I have or substitute it with a negative x to have the function of negative x and try to check whether it would be equal to the original function, then it is an even function. So if I substitute a negative x to the fourth power minus 5 times negative x to the second power plus 4. So you have a degree of 4. So that means negative times negative times negative times negative, it will become a positive. And negative x squared, that will negative times negative, that's a positive times a negative, that would be a negative 5x plus 4. What do we have here? It's the same as the original function given. So in other words, this is our f of negative x. In other words, our function of negative x is equal to the function or to the original function. So if they are equal, then they are even. That this is an even function. Okay, let's have an example of odd. So in odd, it should be that the function of negative x is equal to the negative of function of x. As I've said, when the negative is substituted in the given function and it will come out to the opposite, its term will be the opposite, then it is an odd function. So let's do this. So if I have the function of negative x and substitute it to the function, given function, minus a negative x, what do we have here? A negative x cubed, that's a negative x cubed times 2, you have a negative x cubed. Negative times a negative, that would be a positive x. So what do you see here? Negative 2x cubed is the opposite of 2x cubed. Positive x is the opposite of negative x from the given function. So therefore, you could say that the function of a negative x, if we have the common factor and have it outside as the common factor of 1, we can have 2x cubed minus x. So that means a negative of the given function, right? So in other words, we could say that the function of negative x is equal to the negative of the function of x. That's why this is an odd function. All right? Let's have number 3. Okay. W of x is equals to negative 2x to the 5th power plus 7x cubed. I could tell, if I would say, since our degree here is 3, if you look at the degree here, the degree is even. So you could tell right away, okay, maybe this is even. All right? The degree here is 3, so you could tell right away, okay, this is odd. So what we're doing is we are checking if really this is an odd by the rules, okay, by the condition of what is an even function and what is an odd function. In wx equals negative 2x to the 5th plus 7x squared, I have to think it over because the leading term has a degree of 5, second term has a degree of 2. I have to be sure. I want to check, okay, before I say it may be a negative, it may be an odd, or maybe it's not, or maybe it's even. I have to be sure. So if I substitute a negative x to the function, okay, let's say a negative 2 times a negative x to the fifth power plus 7 negative x squared. So we have a negative 5 to the fifth, that's a negative, times a negative, that would be a positive 2x to the fifth power. Then a negative, it's plus 7x squared. But look at our leading term. It's not equal. The w to the negative x is not equal to the given function. Our given function is negative 2x to the fifth, where w of negative x is positive 2x to the fifth. So we could tell that w to the of negative x, function of w to the negative x, is not equal to wx. Okay, so this is not even. All right. Let's check if it's odd. So in the odd, what's the condition in the odd? The wx should be equals to the opposite of the function. Okay. So let's say, let's start with the opposite of the function w to the function of x. So I would say a negative. I'm making it a negative right away. 2x to the fifth plus 7x squared. I'm trying to check if they will be equal. So a negative times a negative, that would be a positive 2x to the fifth minus 7x squared. Okay? So that means the negative, that means w to the negative, w of the function w of negative x is not equal to the negative of the function given. Okay, because they are not equal. So this is not odd. Not odd, not even, that means it's neither. Neither odd or even. Okay. Let's have number 4. b of x is negative x to the power of 7 plus 8x to the fifth. Our degree is odd. I want to check if this is really odd. Okay? By looking at the degree. So, analytically or algebraically, I will check if it's, if it's odd. So, b to the negative x, I would say a negative. I substitute a negative x to the function to the power of 7. 8 times negative x to the fifth. Negative x to an odd number degree is negative. So negative times negative, that is positive. 8 negative x to the power of 5, that's negative. So we have x to the 7 minus 8x to the fifth power. Okay. How will I know that, it will be this one? X to the power of 7 is the opposite of negative x to the power of 7. Negative 8x to the fifth is the opposite of 8x to the fifth. So I could tell, if I factor out a negative 1, then I could say that this would be the opposite of the given function. Right? So b of negative x is equal to the opposite of the function. Therefore, this is odd. Right? Just substitute a negative x in the function, and you can find out if it's odd or even. Let's have the fifth number, the number 5. M of x equals negative 2x squared plus 6. So we substitute a negative x to the function. So I could tell that this is even. I have to check. Okay, because the degree is even. And it's the leading term, and there's no other degree. So I'm quietly sure this is even. But let's check. So negative x squared plus 6, this will become negative x squared is positive times negative 2. That is negative 2x squared plus 6. So we come up with the same given function. So m of negative x is equals to the function m of x. That is why this is an even function. All right. Let's have the graph. Okay, the graph. All right. When I try to identify a graph, whether the graph is an even or odd function, the first thing that I have to look at is the end behavior. So the end behavior here, it goes up, so it's positive, infinity. Both are on the same direction. That means it's not odd. It might be even. I have to check. Okay? The rule is, because this is, when it's even, it is symmetrical to the y-axis. So x and y should map to a negative x and positive y. That means if I choose some point here, let's say this point, the coordinate here is 3 and 4, positive 3 and 4. And I'll choose the other one, which is the opposite, on the opposite side. The coordinate is negative 3 and 4. You see that if this is 3, 4, it maps at negative 3, 4. What changed is only the x coordinate, and the y coordinate remain the same. So in other words, this is an even function. Okay? Very easy, right? Let's do the second graph. All right, the second graph right here. I look at the end behavior. One is going up and the other one is going down. Therefore, this is not even. That's one thing you can cross out right away and check whether it's even or odd. Try to check it rotates or symmetrical across the origin, 0, 0. That is, when you turn 180 degrees, it will remain the same. So try to imagine that when you turn this to 180 degrees, the position remain the same. And as to the rule, x, y should map to a negative x and negative y. That's the only thing I have to look at. So if I choose a certain point here, let's say, I choose this point right here. This is point right here. somewhat more or less. So let's say this is 2, negative 3, and this point is negative 2 and positive 3. So the point that I have is 2, negative 3. Try to check. It maps to a negative 2 and 3. 2 is the opposite of negative 2. Negative 3 is the opposite of 3. That means this is an odd. All right? Odd. Okay. Let's do this. Let's do this graph. One goes up, one is down. So it's not even. Okay. We'll try to check if this is the origin, 0, 0. If we try to rotate, what do you think? Will it be the same? And if I try, does it map to xy maps to a negative x, negative y? Let's look at this one. If I choose this, this is 1, 3. So I need a negative 1 and negative 3. If I have a negative 1 and negative 3, the other one should be at this point, but we cannot find. So that means this is not odd. So it is neither odd. It's not odd, neither odd or even. And it's very clear in the figure. We have some space here from 0 to negative 2, but we do not have on this area right here. So they are not symmetrical around the origin. Let's do this figure. All right. Both ends, same direction. So this is not odd. All right. Let's look for, a certain point that they are somewhat like, okay, I choose this point right here and choose this point right here. Because this is exactly where, it crosses the x and the y axis. So the coordinate here is 5, 7. And the coordinate here is negative 5, 7. That means it goes with the rule that the xy maps to a negative x and y. All right. If my 5, 7, it maps to a negative 5, 7. See, only the x change. All right, only the x change. So when you try to fold the figure, it is very symmetrical to the left side. That means this is an even function. Okay. Let's do this. Figure right here. Okay, both ends a negative infinity, point down. So this is not odd. That's a condition when it's even across the y-axis. So let's say I choose this point, 5, 0, and this is a negative 5, 0. Across the y, the condition there, it maps, xy maps to a negative x, y. So if I have a 5, 0, then it maps to a negative 5, 0. That means this is even function. Okay. So let's have a reminder. All right. What will be our reminder here? Analytically, a function would be f of x is even. We have to remember this. If f of negative x, when you substitute an f of negative x, is equals to the function of x in all values of x in its domain. It is odd if the function of negative x is equals to the negative function of x for all values of x in its domain. Okay. Now, when we say we substitute, like if we try to prove and substitute the negative x in the set, it should be the same from the original function, then it is even. But if the function, as soon as you substitute the negative x, it will become the opposite of the positive value of x, then it is an odd function. Okay. Graphically, even functions are symmetrical over the y-axis. That is, we have some rule that the xy coordinate would map to a negative xy. That means that only the x value changes. While if its odd function are symmetrical over the origin, then the rule is the xy coordinate is mapped to a negative x and negative y. That's what I've shown in the example. There is a shortcut. Let me say, is there a shortcut without checking, doing the whole thing, if it is the opposite of the function or the function is still the same? Shortcut for simple polynomial function only. Let P be a polynomial of the form P of x equals a sub n x to the nth power, where n is greater than or equal to 1 and a sub n is not equal to 0. What does it mean? If n is even, then the function is even. If n is odd, then the function is an odd function. So for example to that, so if I have here a function of x, let's say negative 8 x to the third power, single term, then I could tell by the degree, I could tell that this is odd. Okay, by one term only. If I'm given like function of x, say 5x to the sixth power, I look at the degree, it's even. So I would tell right away that it's even. If you are given a single term, I have function of x equals, let's say, a negative 3 x to the 8th power. All right. The degree is 8, so I would say it's even. Okay, by just looking at the degree. This condition is for one term, single term. But if you have 2 terms, 3 terms, then you have to check. You might say, oh, this is even, then check algebraically. By look at the condition of the two when it's even, when it's odd function. Okay, let's try this. Okay, I have several graph here. Let's master this one. Okay, state whether the graph represent the function that are even, odd, or neither. I will try to make this big. Okay, as I've said, first thing that I have to look at is the end behavior. Both are facing upward, so positive infinity. So that means this is not odd. I could tell this is even, but we have to check how even is the even. Maybe it's neither. Okay. All right. So I have to, I can figure and I could tell right away, because when I across the x-axis, if I try to fold the figure, they are symmetrical. Okay, they're the same. So for example, I will just choose 2, 0 here, and I will use the condition 2, negative 2, and 0, that if xy, it should map to a negative x, y. All right? So if my xy is 2, 0, so the 2 should be a negative 2, 0. And it answers to the condition. So this is an even function. Okay, the next one is going down. So this is negative infinity. And one is going up, positive infinity. Okay, so this is not even. This might be odd. If it across the origin here, 0, 0. Let's say I choose, a certain point right here. And this point. This is 1, 2. Maybe 1.5. So this might be 1.5 and 2. So here, all right, here and here, this is 2, a negative 1.5. This is a negative 2. That means that the x, y map to a negative x, negative y. So if my xy is 1.5, okay, this point is negative 1.5, negative 2. Okay, this map to a negative 1.5 and negative 2. That means this is odd function. Okay? Next. Okay, let's have this. All right, you can tell. Opposite and behavior. This is odd. Okay, let's check how odd is odd. So if I choose across the origin, 3, negative 3. If I choose another point right here, it's negative 3 and positive 3. So doing the condition that xy should map to a negative x, negative y. So if my xy would be 3 and negative 3, maps to negative 3 and positive 3. So what's the opposite of 3? Negative. What's the opposite of negative 3? It's positive. That means this is an odd function. Odd. Okay. Let's do another graph. Okay, let's do this. This is going up positive and this is negative. So this is not even. We'll have to check if it's, it's odd. All right. Where is our origin here, right here? When we try to rotate it into 180 degrees, can you figure it out that the figure would be the same? I think it's not, right? It's not. And if I'm not using the rules of mapping, the distance from 0 to here and 0 to the other side are not equal. Okay? And also the gap here and the gap, the curve, they're too far. Okay? So I could tell, like, if I choose a certain point here, I'm quite sure that they don't map to each other. So this is not odd, this is not even, so this is an example of neither. You can tell from the graph itself. Let's look at this. Oh, I put some markings here. Say, okay, I'm gonna take that out. All right. Both ends pointing negative, infinity. So you might think, oh, this is positive because both are negative. So we'll try to check. We'll try to check if this point 1, 1 map to this point right here, -4, 1. Thus, it goes with the rule that xy should map to a negative x and y. Okay? So, if my 1, 1, does it map to -4, 1? No, it doesn't. That means this is not odd, this is not even. So, this is an example of neither. Okay, you can tell from here to here and from here to there that it's far from being symmetrical across the origin. Okay, let's do this figure. One is up, the other one is down. So this might be a odd function. Okay, across the 0, 0. That's one thing. Next, we try to choose some points here. Okay, can we do this stuff right here? This is 1, right? This is -2. And this one right here, I'm talking about this point. This is -1. And this is -1, right? Oh, wait, I made some mistake here. It's not -2, but this is -1 as well. And the top is +1. All right. If we try to figure out it rotates, let's say the condition xy must map to a -x, a -y. So if our x, y here, this coordinate is 1, -1, 1, -1, the 1 should become a -1. This coordinate is -1 and +1. So -1 and +1. So the +1 becomes a negative and the -1 becomes a positive. That means this is an odd function. All right. Let's have the last 3 figure. Okay. Both are negative facing down. Okay. It should be across the y-axis, symmetrical. It seems they are very symmetrical. So, but let's just try to check by doing the mapping, -xy. So let's say this point, this is 1, 2, 3, and 1. And this point right here, 1, 2, 3, -3, and 1. Right here. So 3, 1 maps to a -3, 1. It answers the condition? Yes. So this is an even function. Let's do this. Opposite. 1 goes up, 1 is down. So it must be across the origin, 0, 0. And let's do the xy maps to a -x, -y. Let's choose some points right here where it exactly hits this point is 1, 2. And this point is -1, -2, right? So 1, 2 maps to -1, 2. I'm looking at the point where they exactly meet, crosses the graph, and exactly meet at a certain point with respect to the x and the y axis. So one opposite is -2, -1, and this is -2. Okay, so this is an odd function. Let's have the last one. So goes down. Both are facing down, negative infinity. So it should be across the y-axis. It's very clear. If I choose this point right here, it is 3. And this is 1, 2, 3. And the other side, this is -3. And this is 3. So the coordinates here is -3 and 3. Does this answer with the rules of xy? When you map it, it should be -x, -y. So if our xy is 3, +3, that would be a -3 and 3. So this is an even function. Okay? Easy, right? If you just look at the end behavior and the condition of mapping the coordinates, then you could tell right away whether it's an odd or an even function. Okay, let's do this. State the following functions are even, odd, or neither. Okay. If I look at, number 1. If I look at the first one, function of x is equal to 3x to the third minus x. If I look at the degree, which is 3, I could tell that this is odd. Okay? Just because by looking at the first term degree, I could tell. But we have to check. Remember the condition that if you say this is odd, that means the function of a negative x should be equal to the opposite of the function of x. Okay? So if I substitute if I substitute 3x to the -3, to the third power minus a negative x, I would, a negative x cubed is a negative. So that would be 3x cubed plus x. So if you try to factor out a negative, so that would be a 3x cubed then minus x. And it gives you the function, the negative of the function. That means the function of negative x is equals to the negative of the function of x. All right, so that means this is odd function. Okay. For the second one, you have f of x equals 11x squared minus 18. So the degree is even. I have to check. I'm quite sure this is even. So algebraically, I will check by substituting a negative x to the function. So 11 times -x squared minus 18, that would become negative squared. That's a positive, so that will be 11x squared minus 18. Still the same thing as the given function. Our given is 11x squared minus 18. So therefore, I could tell that the function of negative x is equals to the function of x. So therefore, this is an even function. Okay? For number 3, 2x to the fourth power minus 6x squared plus 8x. I'm not quite sure. I know this is even, and the next term is even. We have 3 terms actually. So I have to figure out. I could not tell right away. I have to figure out whether it is odd or it is even, or let's figure out. Let's check. Okay? Supposing I do the checking here. I have f of negative x. That means I substitute a negative x in its term. And let's check what happened. Okay, so I have negative x to the fourth power, that's positive. So that means 2x to the fourth. Negative x squared, that's positive. That means negative 6x squared. And 8 times negative x is negative 8x. Will you come up with the same as the given function? What differs here is this. So, in other words, the f of negative x is not equal to the function of x. So, this is not even. Okay, not even. Okay, I have to check if this is an odd. Right? What happened if I do it in checking if it's odd? So, a negative f of x would become, I put a negative outside, 2x to the fourth minus 6x squared plus 8x. Okay, I have to, okay, by doing that, I could say negative 2x squared, distribute, change the sign, and distribute. So, by doing this, even I factor out a negative 1, that would become negative 2x to the fourth. That means f of negative x is not equal to the negative of the function of x. So that means this is not odd. If this is not odd, not even, so this is neither odd nor even. Okay? Let's do the fourth one. X cubed plus x. X cubed. I could tell it's odd. Okay? So if it's odd, I think I have to move this number 5 here. Oops. To have a space, g of x equals x to the fourth plus 3x squared. Alright, I need a space. I said it's odd. Okay, let's check. By substituting a negative x, so negative x to the third power plus 3. So this will become a negative x cubed plus 3. That means f of negative x is equals to the negative, okay? So when I factor out a negative, so it will be a negative of x cubed minus 3. So f of negative x is equals to a negative of the function of x. So this is x to the fourth plus g plus 3x squared. Okay, the last one. If I substitute a g, I could tell this is even. I look at the degree. So let's check. G to the negative x, that is negative x to the fourth plus 3 negative x squared. X to the fourth, negative x squared, that's positive, so you have 3x squared. That means the function of g of negative x is equals to the function of g. That's why this is even. All right. I want to go back here. Oh, this is supposed to be a negative. Well, hold on, I'm trying to figure out here. So from here, I could tell right away. All right. Okay, so we're done with the add and even functions. So in my next video, I will be doing problems and solutions of odd and even functions. So what I can say now, if I can do it, so can you. Please hit the like button and hit the subscribe button. See you in my next video.